Beneath Jupiter's beautiful swirling clouds, the planet is not what we thought. For centuries, we have gazed upon its striped face, a canvas of storms and serene bands. But this is only a veil. NASA's Juno spacecraft dives close, listening with microwaves, gravity, and magnetism to read the depths we can't see, to translate the planet's hidden language. In the next few minutes, the fastest tour of what truly lies below the clouds. Juno arrived in 2016, a solar-powered explorer slipping into a unique polar orbit that skims just thousands of kilometers above the cloud tops. This path allows it to map the entire planet, pole to pole, avoiding the most intense radiation belts. Its tools, a microwave radiometer, precision gravity tracking, and a magnetometer, are designed to probe down without light. The clouds are the surface we see. The real science lives deep beneath. How do we know what's there? Microwaves, for one. They pass through the upper haze, returning fingerprints of ammonia and water. Juno's radiometer has 6 separate channels, each tuned to a different frequency. The lowest frequencies peer deepest, hundreds of kilometers down, while higher frequencies sense the layers just below the visible clouds. Gravity harmonics, measured by tiny shifts in Juno's radio signal, reveal mass flows deep inside. And magnetic maps, built from repeated passes, show a lumpy, uneven dynamo. Not pictures, patterns, not colors, fields. The Great Red Spot, Jupiter's most iconic feature, goes astonishingly deep, hundreds of kilometers below the cloud tops. It's a towering vortex with roots that extend well beneath the painted swirls we see from afar. This isn't a surface smear, but a colossal storm with a spine, its structure and energy defined by its immense depth. And those famous striped bands? The jet streams are not skin deep. Juno's gravity data shows these powerful winds sinking thousands of kilometers into the planet, far deeper than anyone expected. This means the atmosphere and the deep interior are dynamically coupled, trading momentum across vast distances. The weather we see is just the surface expression of a planet in motion, all the way down. At the very center, we expected a small, dense, rocky ball. Instead, Juno found no sharp boundary. Jupiter's core looks fuzzy, a vast region where heavy elements like rock and ice are diluted, mixed into the metallic hydrogen that surrounds them. This blurred heart challenges our models of planetary formation. Perhaps a violent head-on collision with another massive protoplanet in the early solar system shattered Jupiter's original core, scattering its contents. Weather here runs vertical, in a way we never imagined. High in the atmosphere, ammonia and water churn, building what scientists call mushballs, slushy hailstones of ammonia water ice. These grow heavy, then sink, dragging those volatile chemicals downward. It's a silent, planetary-scale conveyor belt, moving chemistry through the depths and explaining why some upper layers of the atmosphere are surprisingly depleted of ammonia. Lightning crackles in surprising places. We knew Jupiter had lightning, but Juno found it in unexpected forms. Shallow lightning, small, bright flashes high in the atmosphere, flickers across Jupiter's night side, originating from clouds containing ammonia water solutions. Meanwhile, powerful deep bolts, more like Earth's, fire far below the main water clouds. 2 distinct electrical weather systems, operating at different altitudes. Over the poles, a spectacle of stunning geometric order. Polygonal swarms of cyclones hold their shape. An octagon at the North Pole, a pentagon at the south. These colossal storms, each wider than a continent on Earth, rotate in slow, organized chaos, locked in a delicate dance. They remain stable for years, yet are always gently shifting, their persistence a beautiful puzzle of fluid dynamics. Jupiter's magnetic field is profoundly weird. It's lumpy and highly asymmetric, unlike the relatively neat fields of other planets. In the northern hemisphere, it's orderly. In the south, it's a chaotic mess. A massive anomaly, the Great Blue Spot, drifts eastward, a localized region of intense magnetic flux moving with the deep winds. At the poles, this strange field funnels charged particles into the atmosphere, creating the most powerful auroras in the solar system. Even the amount of water is not uniform. In 1995, the Galileo probe dropped into one specific spot near the equator and found Jupiter to be surprisingly dry. But Juno's measurements across the entire equatorial region show that water is far more abundant. Galileo simply descended into an unusually arid weather system. Composition varies with latitude. Jupiter is striped in chemistry as well as in color. How can we be so sure? It comes down to physics. As Juno flies over the jet streams, their immense mass tugs on the spacecraft, minutely altering its speed. On Earth, giant antennas of the Deep Space Network track these changes as a tiny Doppler shift in Juno's radio signal. By analyzing these signals, scientists map the gravity field, and from that, they deduce the depth and mass of the winds below. Each of Juno's orbits, called a perihelion, is a frantic, data-gathering dive. With every close pass, the mission stacks signal on top of signal, refining the maps of winds, depths, and fields. These are whisper-faint clues, amplified by patience and repetition, turning noise into a clear portrait of the planet's interior. The early results upended our tidy models. We learned of deep jets, a diluted core, storms with powerful roots, and chemistry constantly on the move. The planet is more layered, more complex, and more alive in motion than the static pictures ever suggested. Jupiter is not a placid giant. It is a world of deep, churning consequence. We unlearned the simple picture. No neat core, no shallow winds, no storm decals pasted on a surface. Jupiter is a planet of gradients, of mixture, of motion stacked in depth. What we see is just the beginning of the story. So what remains unknown? Many questions still linger in the depths. How far down do the deepest jets truly fall before the magnetic field breaks them? How wide does the diluted core really spread? And what does that tell us about the birth of our solar system? And how do the cycles of water and ammonia evolve over decades and centuries? The path forward is clear. More Juno passes, more careful stacking of signals to sharpen the image. Future missions, like Europe's JUICE and NASA's Europa Clipper, will focus on Jupiter's icy moons, but their instruments will also add crucial context to our understanding of the giant planet itself. Patience turns faint patterns into structure. Take a slow breath in, hovering above the cloud tops. Lightning flickers far below, a heartbeat in the dark. And a long, slow breath out, letting the questions fall into the depths, where invisible fields carry answers back to us across hundreds of millions of kilometers. We still can't see the depths directly, not yet. But with microwaves, gravity, and magnetism, Jupiter is speaking. And for the first time, we are beginning to understand.